So, good afternoon, guys. Welcome to our Dynamic Talks 88 by Grid Dynamics. We are very glad that you have joined us. Today, we are waiting for 2 lectures in the field of data science. We will wait a little more so that everyone can join. And while I'm going to introduce our speakers today, but a little bit later. Firstly, I want to give several minutes to my colleague, to Marika, to represent our company. So Marika, are you ready?
Yes, of course. Hello, everyone. So as we are waiting for everyone else to join, I will tell you a little bit more about our company because as I know, not everyone know about Grid Dynamics. The Grid Dynamics is a leading provider of technology consulting, engineering, and data science services, Fortune 500 corporation from financial, technological, and retail sector. Our company has been operating since 2006 and is headquartered in California and has development centers in United States, Eastern and Central Europe. So as of today, Grid Dynamics brings together more than 3,500 engineers in 14 different countries. As you can see, we have a large amount of different offices in different countries, and we continue to grow up steadily. So Grid Dynamics is a NASDAQ-listed public technological service company with core expertise in big data, data science, machine learning, and IE, scalable omnichannel services, DevOps, and cloud enablement. Also, you can find more information on our site, griddynamics.com. And to understand who we are working with, you can see the list of our partner and clients in different spheres like tech, finance, retail, and others. More information you can find also on our career side. And if you want, until we're waiting for people to join, you can go by this QR code to our site and search for some career opportunities if you want, or read more about our company.
So today we have 2 lectures in the field of data science, and the first speech will be from Denis Tcvetkov, Senior Data Scientist at Grid Dynamics, with speech about GAIA, exploring how gamers choose games. And after that, we will have a small QA, and after the second speech, Anastasia Ovchinnikova will speak about recommendations for e-commerce. During the lectures, you can ask questions via Zoom chat. After the report, the speaker will answer them. Please note that the questions will be seen by all participants of the meetup. We will also make a general QA block after all the lectures where you can use your microphone to ask questions or to discuss something. So, Denis, are you ready?
Yes, I'm ready.
Share your presentation and please start. Thank you.
Okay. Thank you. Hello, everybody. Again, my name is Denis Tcvetkov. I'm a senior data scientist in Grid Dynamics. And now I want to tell you about my and my colleagues' project, Latent Gamespace, exploring how gamers choose games. Let's start. Okay, first plan. I want to tell you my project. That my presentation consists from introduction, goal, dataset that we used, modeling pipeline, the biggest part of my presentation, and conclusion. Let's start. Introduction. Firstly, the video game industry has grown from some focused markets to mainstream in the recent years. I think you can see it. Games are everywhere now. And as of 2018, video games generated sales of more than $130 billion annually worldwide. A huge number of games are entering the market every day right now. And in order to increase profits, you as a company, development company, need to understand what place the released game will take on the market and who will be its main competitors. There are a huge number of game titles of various genres on the market at the moment. Navigating them is really not an easy task, even for companies developing and distributing computer games. There are some games on the screen, maybe you have played some of them, maybe played all of them, but still that's a little part of games on the market. In addition to the genre, whether two games will be direct competitors is influenced also by culture around the game, the time of the release, the setting of the game. Is it about pirates, about space, about Lego, for example, and etc., etc. So it's really difficult to take everything into account at the same time. So our goal of our project is develop an algorithm for finding the main competitors of upcoming new titles. That's really important. Like we want to understand not about released game, but upcoming title. Dataset. What had we used? We used reviews that are written by real game users. We got them from Steam and Metacritic. From this user level data, we want to build a latent space, which is a compressed representation of how do games relate to each other. This data really helps to understand consumers' behavior, not only divide the games by some formal criteria like genre, engine, setting, etc. It's like players play games, not like we think players play games. Let's go. Some statistics about our data set. From Steam, we parsed comments. We used about 38,000 games. And for them, we got 50 million reviews. For PlayStation, there are less reviews. It's Metacritic, there are less reviews for every game. And less games on PlayStation, of course. It's 6,000 games and a little bit more than 100 reviews. And for Xbox, we have a lot less games. It's 3,033,000 of reviews. For next-gen consoles, on the moment we done this project, there was 35 games for PlayStation 5 and 25 for Xbox Series X. So next-gen consoles absolutely out of scope. Modeling pipeline. Firstly, we prepared player game metrics data. I will tell about all these steps separately, just to be sure. Next, we trained a neural network model on game player data and transformed it to n-dimensional latent space. Next, we used embedders. We used TSNE in this project to reduce dimensionality to two-dimensional and plot it. And after understanding what we done, we used metadata. I'll tell about this later, to put new titles on game map. First, data preparation. From the collected reviews, we make a two-dimensional matrix. In this case, we are interested whether this player played these games. We don't interested in review, in text, in the rating. We're just interested if this player played this game. So here is the example. Is for table. For example, there are some games and there are some users. This user played these two games and haven't played this. This user played these two games and this user played only this game, etc. So here is our data set. We used a dense autoencoder model in this project. Here you can see some example of autoencoder. And the interesting parameter here is number of neurons on latent space layer. Like the shortest layer, smallest. And we got results that for Steam, we got best results with 4,096 neurons, and for PlayStation and Xbox, we got best results with 2,048 neurons. We used REL, we experiment with different parameters, their actuators, but REL is fast and good for this, our goal. And we used as an output layer activation function, we used sigmoid, because we need to get from 0 to 1, some number. Okay, let's go. We draw two-dimensional game space representation of how do people interact with the games. The game space is flexible, can be redrawn for more games are released. Some facts before I show this game space. Players on console have really different experience versus players on PC, and they behave differently, really different. And interesting thing, PlayStation and Xbox players have their own console-specific popular franchises, like Detroit on PlayStation, for example. So this forces us to develop game spaces separately for each platform. And let's go and look into our game space. Sorry guys, we have some censorship here because we don't want you to know what company we have done all this for. Okay, let's look into it. This is our latent two-dimensional representation of our latent game space. It's separated by some clusters. You can see them here. For example, this cluster is only VR recurred games with some games for virtual reality. And we found a lot of different clusters. We found cluster with classic games like Max Payne, Need for Speed Underground, Red Faction, etc. We found strategy cluster, we found cluster of sports games, etc., etc. And we checked the game we have studied is released every year, and we checked that all previous releases, all previous releases of this game, and they was like in really one point. They was really close to each other. And the interesting thing that we found, that new game that came the year we done this project, it's really far from old games. It's in another cluster. There is new sports games released. Here you can see the games that we found that are really close to our game. It's like tennis, FIFA 21, NFL 21, and some other games 21 that we got here, wrestling for 2K22. Yeah, and also we studied another game placed here, and we got that nearest games to this game are really similar to this game. They really looks like the game we had studied. Okay, let's go on. That was for Steam, and now we are looking for PlayStation game space. For PlayStation, we have less reviews and less games, so the results are really less accurate, but still there are some good results. For games we studied, we got, for example, here, as I remember, it was some RPG, and with we got Elder Scrolls. No, RPG was the second. The Elder Scrolls here, another Elder Scrolls, Dark Souls, another Dark Souls, etc., etc. And the last game space is Xbox game space. It looked like these, and for Xbox we got less accurate results even for the PlayStation. But still there are some good results for our game. But the idea, what do we want to do? We want to place new plans to release games on this map. How we can do it? We can use metadata about game to find the position and neighbors of new unreleased now game. Position is really very dependent on what are the metadata is given by the studio. So our studio told us that this would be game about sea, about pirates, about something. This would be a 3D game. This would be a first-person game, etc., etc. But we also need metadata for all the games we had in Steam space, PlayStation space, and Xbox space. We checked different sources of this data. You can see some of them there. And just to give you an example what features we had, general features for the game. We got like release date, franchise, genre, theme, age rating, etc., etc. But the most interesting data that we got was an NPD data. This data was bought for us by the company from another company who's collect game data, metadata about different games. From there, we got really interesting features like camera and control details, game requirements, game combat, co-op mods, multiplayer functionality, technology level, game universe, target audience, etc., etc., etc. Around 200 features we got from this data set. And this really allows us to understand people's choices more precisely. Okay, and let's see, we used this data to train our data set and to place a new game, its codename, to place this new game on the our gamespace. And we got that for this certain example, for the game, it's RPG with some specific settings. We got metadata about this game. We got these nearest games, a lot of Lego games and some open world games. It was an open world game that we got, and you can see it: Watch Dogs, Just Cause, Far Cry, another Watch Dogs, etc., etc. And also the RPG, South Park. There are some RPG system, as I remember. Okay, let's go on. This is all about our project. I want to tell a little about it. That was a good automatized project. Our solution has significantly optimized the work. Previously, company analysts had to manually collect and analyze data on direct competitors. They try to think what game can be competitor and etc. etc. Now this process is automated. Just press button. You just give into the data set information, metadata of game that would be released, and you can get competitors of this game. Time to market. Our solution has significantly reduced the time to result because the whole process from data collection to the final result is automated. The longest point is collecting data from Steam, but it does not need to be done every time because like big AAA games, they of course sometimes released on the market, but you need to wait for some new comments, etc., etc. So you can collect this data like 2 times a year, 3 times a year, and all other processes really fast. And reliability. Our solution is more reliable because the algorithm does not rely on some human assumptions about how similar games are to each other, but work with clear data that's directly related to how people play games. So that's all that I want to tell you today. Maybe some questions.
I have one about the selection of the data set. So when you took the Steam data set and you ended the Xbox one, did you exclude from Xbox what is also available on Steam, or you have duplicated data sets based on the console?
No, we have separate models and separate spaces. So we haven't removed anything because it's like 3 different approaches, 3 different latent spaces. So we have like the same, we can have the same game in Steam, Xbox, and PlayStation, and you can get output like what competitors you will have on Steam, what competitors you will have on PlayStation, and what competitors you will have on Xbox, because there could be different games. You have some games, for example, Detroit, that you have on PlayStation and don't have on Xbox, and that time you don't have it on Steam. So,
okay.
Yeah.
Okay, thank you. Was just surprising the difference in catalog and reviews. It was really huge. It's just about the the provider, right?
You mean about that we have different lists of games in Steam and PlayStation and Xbox?
Yeah, mainly the number of games and also the number of reviews. So the two data sets were really big in terms of count.
That's because Steam have really good commenting platform for it, and not everybody will go to Metacritic and put some comments there, and you can't like do comments in PlayStation Store on Xbox Store. As I remember, maybe now they have some platforms, but at that time there was no platform for commenting games for Xbox, like in the Xbox Store. So yeah, Steam is there are much more data in Steam.
Yeah, thank you.
Thank you.
We have one question in chat for you. Can you open chat?
Yeah, I'll check it. Did you count how long a player was playing a game, or just how he launched it once, so he played it, for a two-dimensional matrix? No, we hadn't count it. We are interested in like maybe just really started this game and closed, but in the average, yeah, we haven't counted because in average, people played a game some hours. I think we checked the average. Even, of course, there are some small games, there are some large games, like in the sense of time you spent this game. But we are really interested, like if he starts this, and this game, so maybe there are some connections between these games. Maybe not, but we have a lot of data. We have a lot of people who started this and this game. And if we see that a lot of people who had Red Faction had Max Payne, it seems that they're maybe close to each other. So yeah, I hope I answered it. Yeah, thank you.
Okay, so someone else? I think we will ask other questions after the second speech. If someone will have a question to you, we will answer. So I think we will move on. Thank you, Denis.
Thank you, and thank you all for your attention.
Yes.
Yeah.
And the next speaker is Anastasia. So are you ready?
Yes, hi everyone.
So Anastasia Ovchinnikova, our data scientist at Grid Dynamics, with her speech recommendations for e-commerce. So you can share your screen and start. Thank you.
Okay, hi everyone. Can you see my screen?
Yep.
Okay, so my name is Anastasia. I'd like to discuss my experience connected with recommendation system for e-commerce. And let me say a couple of words about myself. My name is Anastasia Ovchinnikova. I'm a data scientist. I've been working with Grid Dynamics about 18 months, if I calculated correctly. And my main interests in data science is anti-fraud detection, users classification, and of course, recommendation systems. This is the agenda of my presentation. Let's start from the first point. Why recommender system is important. I guess all of us understand what are recommendations very well, because we face them every day while using different services. Online shopping, streaming services, music applications, banking applications, social networks, and so on. And recommendations became an important part of user experience. They increase sales and conversions. They provide user loyalty and reduce churn. And now people are used to getting engagement and good quality recommendations, and they can feel frustrated or even decide to stop using service if they don't get good recommendations. That is the main reason why some IT giants such as Google, Netflix, and Amazon spend enormous amount of money and resources, put a lot of effort to create an intelligent and good quality recommender systems to meet these high user expectations. And I guess most of us are aware of this funny fact about Netflix price. And so maybe you know that they didn't even implement the winner solution, the most accurate one. But the fact that they offered $1 billion for the most accurate recommendations showed the importance of recommendations for business. Okay, now I'd like to talk a little bit about subject area because it's important for understanding the whole problem. For different situations, solutions will be different. If you're talking about music application, we want the recommendations to be various and to reflect our preferences very well. And if you get the same recommendations from day to day, you will get bored and stop using the application. But situations a little bit different if you're talking about e-commerce area. In this case, we want to encourage people to buy something, and especially something expensive. Engagement is important as well, but the most priority is our revenue. So my goal was to create recommendations for large e-commerce company, which includes several brands. And I listed the main products here. It's furniture, kitchen equipment, home decor, and so on. Well, let's talk a little bit about types of recommendations. There are three main placements on the website where recommendations are shown. The first one is people also viewed. This section is shown on the product information page, and here we want to show similar items. It's reasonable. The second one is people also bought, and in this section we want to show some complementary items to encourage people to buy something else to increase our cross-sell component. And the third placement is the most tricky one. It's items related to your cart, and it contains the mixture of both similar and complementary items. The reason is that there are two different scenarios of using cart. Some people add to cart products only if they want to buy them, but another group of people add some items to the cart, and after this they do some comparison and choose the final option. Because of that, we need to show some mixture of approaches for this third placement. Let's consider the example. If you're looking for a bed and you've already got lost in this huge variety of different products, it's logical to show you some similar beds so you can choose the most appropriate one for you. But if you have already bought a bed, you're likely to look for some complementary items such as quilt and sheet set, and it's reasonable to show some items to encourage you to buy more products. Well, regarding data, the main data that we have and we used for our system is clickstream data. We record and store all events that occur on the website. And here are the most significant fields. I listed these fields on the slide. The important field is timestamp because our approach requires manipulation with product sequences, and order is important. Also, there are three main types of action available for user: view, add to cart, and order. These types of actions are connected with placements that I described before. And we can consider these types and assign different weights to them depending on the placement where we're gonna show these recommendations. Some information about product, such as price, is valuable too, because we can use it to find outliers, to remove some noise from data, and we can take this information into account to increase our revenue. Okay, let's talk about some difficulties connected with recommender system. I face these difficulties, but I would say they are common for most of such problems. The first one is data sparsity. The matrix user item is sparse because of the large variety of products. And the second important and painful issue is called start problem. When a new product appears in catalog, we have no statistics for this product, and we still need to show some recommendations for this product, but how can we get them? The second one is seasonality. Users' behavior can change dramatically because of seasonal reasons, such as winter holidays, for example, and we need to consider such events in our system. The last one is lack of statistics for some products. Some products are not very popular, and we just don't have data to create recommendations for these products. Okay, now I'd like to discuss association rules approach and go through the main concepts of this approach. If customer buys beer, he's 70% likely of buying diapers. It's a funny fact, but yeah, looks like it's true, and we can calculate it. And so the main idea of association rules approach is market basket analysis. We can analyze some chains of products and create some relationships between products based on these statistics. So how we create these association rules. If you think about some supermarket, for example, all vegetables are placed in the same aisle, all dairy items are placed together, and cosmetics form another set of such groups. And the association rules approach can help to uncover all such relationships between items from huge databases. And in contrast with collaborative filtering, it's wisdom of crowds approach, and we don't take into account some individual preferences. And in my case, it's a huge advantage because we don't have any information about user profile. And this approach not only reduces customer shopping time, but also reminds the customer of what relevant items they might be interested in buying. Thus, it helps stores to cross-sell some items in the process. Here you can see the most significant values that we need to calculate for this approach. The overall approach is pretty simple. It's not a neural network or reinforcement learning or something else. So it's about some basic statistics. So the first value is support, and this measure gives us an idea of how frequent an item is in all transactions. Support is the fraction of the total number of transactions in which the item occurs. So it's mainly just probability to see this item based on the all statistics. The confidence is nothing but conditional probability to see the next item if you already have the first item. This measure defines the likeliness of occurrence of consequent on the card, given that the card already has the antecedents, in other words. That's to answer the question of the all transactions containing, say, bread, how many also had milk on them. And the third one is lift. A lift controls for the support of consequent when calculating the conditional probability of occurrence of the second item if we have already the first one. Let's go through the algorithm. It's pretty simple. We need to create a set of all products. We calculate support for each item X based on our clickstream data. We calculate confidence for each pair, X and XI. And we can calculate lift for each pair as well. We can order our pairs based on this confidence, take top N, we order them in decreasing order, obviously. And so that's how we create a recommendation list for item X. So if user is viewing item X, we will show them this recommender list. And we can use lift in case of equality of values of confidence. And also we can consider different types of relations between items and assign different weights for them. And it's one of parameters of our model. Okay, now I'd like to discuss advantages and disadvantages of this approach. The most obvious advantage, it's very simple. It's not time and resource consuming. It's easy to code. It's easy to interpret. You can describe this approach to your product owner or manager, not technical person, pretty easily. And it's really easy to understand. But disadvantages are here as well. Recommendations are not personalized. So we show to all users the same list if they are viewing the same item at this moment. And we don't consider some meta information about products. I mean, some image or maybe a text description or comments that the user can leave under this product information page. Looks like we can use it to make our recommendations better. And of course, it's exploration versus exploitation problem, the common issue for all recommender systems. But in our case, I would say that exploration is not as important as for music application as well, because in this case, it's okay to show the same recommendations from time to time. If people buy these products, if they click, it's okay. Okay, the approach is very basic and simple, but there are some set of improvements that we can do to make our recommendations better. And the first point is obvious. Do not show no longer available items in the recommendation list, because otherwise people will be frustrated. And the second point is use time decay function. As we have timestamp in our clickstream data, we can calculate some period from item to item. And we can assign little weights to this long periods between items, so we can consider time as well. Also, we can combine long-term and short-term models. What I mean here, we can take several months as training set, or we can take just 1 month, and we can create a hybrid models and combine their recommendations, create single list from them. Also, we can use day of the week factor. For example, if we see that sofa is purchased pretty frequently on Mondays, it's possible, and we can boost these products if we gonna show them on Mondays. Also, we can suppress items with the same category for complementary recommendations. For example, if user has already bought sofa, we can suppress all items from the same category, because it's unlikely that they will buy something expensive again. It's more likely to buy something complementary like mattress pad or comforters or something else. Okay, the important question is quality, and let's discuss it. We use common metrics to evaluate quality of our model. It's precision at GAIA and indicatory. These metrics are widely used for search analysis and for recommender system as well. Let me remind a little bit some details about this metrics. So you consider two lists. The first one is your recommender list, and the second one is some ideal list that you can get from your data. Do you find the intersection between them, these two lists? If the intersection is big, you're good, your model is good, everything is great. But if the intersection is small, it means that your model isn't very good. And indicatory is the same thing, but we can consider order in this case. So we can assign lower weights for items that are in the end of the list. That's the main difference. And what's about metrics that product owners measure? They measure different metrics. They measure CVR, RPV, AOV, and frankly speaking, it's a very frustrating situation because you can spend a lot of time, you can create a great model, you can evaluate all metrics, calculate them, get great numbers, and after that, during A/B test, you will see decrease in RPV, decrease in revenue, and so on. And everybody will be unhappy. So what's the answer to this question? What we can do in this situation? We should somehow incorporate price to our metrics to optimize for revenue. And I'd like to discuss so-called expected value. We can consider not confidence for pair of items, but expected value. So it's confidence multiplied by price. And we can reorder items in the recommendation list using expected value. And, I need to say that this approach can be dangerous because we can boost very expensive items, but these items can be irrelevant for our seed item, but we're gonna show them and it will decrease engagement. So we need to be careful, but if do it wisely, we can create a new metric that will cover all data scientists and product owners' needs. Okay, what's about issues and how to deal with them? Sometimes recommendation list is too short. We have no statistics for some products, so we can't create enough recommendations for them. In this case, we can use backfill model based on, for example, category top sellers, and it can solve this issue pretty well. Data is noisy, it's a normal situation, and how we can deal with it, we can involve some information about products such as price, category, theme, some additional meta information, and we can filter out some outliers based on this information. The next one is no exploration, and we can resolve pretty easily, add some randomness to our recommendations, make them more various, but you need to be careful with this. So recommendations are still good quality. Yes, that's it from my side. Thank you for your attention. If you have any questions, I will be glad to answer them.
Yes, we have one question in chat for you. Can you open it?
Okay, I see. What benefits would we get from combining long-term and short-term models? Okay, thank you for the question. So if we consider some small period of data, for example, 1 month, we can capture some trends that appears that has just appeared. So, for example, we can take into account some overall trend. For example, it's winter, people buy some warm clothes, so on. But if we take into account some recent data, we can capture recent trends as well. For example, it's Christmas time and people start buying some ornamental things, some home decor. And by combining these two models, we can capture both long-term and short-term trends. That's the main reason of use this approach.
Thank you, Nastya. Maybe someone else have questions you can ask by microphone or in chat. Okay, I think that your speech was so clear. So anyone has not questions. So we have.
It's for Denis.
I see it. 1 minute. Question for Denis about his presentation. Maybe I missed this part, but did you use features of games, RPG, strategy, co-op, not co-op, etc. in the clustering algorithm, plotting two-dimensional plot, or use only user-played games table? Yeah, for plotting it, I used only table players games. So we don't have any information about what's genre, what is it, co-op or not co-op, strategy, not strategy, setting, etc. We want natural information about how people play games. And all these features we used, then we want to place new game on this latent space. Had I answered question?
Okay, thank you, Denis. So anyone else? Yeah, Ruslan wrote that. Thank you. Okay, so I think that we have not questions for now. Thanks to everyone. Thanks to our speakers, Denis and Nastya, and thanks to everyone who joined us at our meetup, and thanks to our second moderator, Marika. The recording of the conference will soon be posted on YouTube on our channel Grid Dynamics, and you can share it with your friends or rewatch again. So good evening, everyone, and thank you. Bye.
Thank you, everyone, for
Bye.
joining. Have a nice evening. Bye-bye.